Hello everyone, you are welcome to my YouTube channel. In this video we are going to look at one practical aspect of current electricity. Our aim would be to verify Ohm's law. You would recall that to determine the relationship between current, voltage and resistance, George Simon Ohm stated that the current which flows through a metallic conductor will be directly proportional to the potential difference connected across the resistor if we keep temperature and other physical conditions constant. Now in this video lesson, we shall attempt to verify the relationship between voltage and resistance. Remember, there are three quantities of interest in Ohm's law: current, voltage, and resistance. But in this experimental verification of Ohm's law, we shall focus on the relationship between voltage and resistance. Let's take a look at the screen, and you see, according to Ohm's law, that I is equal to V over R. Now, if I is equal to V over R, basic, you notice that if you make V subject to the formula, it's going to be current times resistance. Now, let us take a look at something. If we make current, let's say constant per se, you will notice that voltage will be directly proportional to resistance. What does that tell us? If you increase the voltage, of a particular electrical work, then you expect the resistance to also increase. Or perhaps if you increase the resistance, you expect the voltage to also increase. So that's just the whole idea of Ohm's law. Therefore, in this video, we shall attempt to look at this relationship between voltage and resistance. And I hope you are ready as we look at this experimental demonstration. Please come with me as we make use of the necessary equipment required in order to verify this relationship between voltage and resistance. Alright friends, so we have here the apparatus that we are required to use in carrying out this experimental verification of Ohm's law. Here I have my connecting wires, so I'm going to cut the number of wires I need for this experiment. Okay, this is a connecting wire. It's going to serve as our conductor. With me is the voltmeter. This is your voltmeter. I'm sorry that I already connected these conductors, this wire. Ordinarily, the wire is not connected with this. I just decided to fix it up to do the connection there, because usually I use this point. You can see the screw, screwing it off, you can see that. So the wire is tied round this screw to make contact there. Okay, let me screw it back. Let me tighten it back. You want to ensure a level of tight connection. Okay, then this one with the black cap, you can see also, like I said, these conductors or wires were not there originally. Okay, as the one that tied the wires there, because I need these 2 points. Alright, so we fix them back. You can see a voltmeter. The voltmeter has 2 readings, or 2 scales rather. We have the lower scale, which measures from 0 volts to 3 volts. And we have the upper scale, which measures, if you have maybe a cell, I want to measure voltage up to 1 volt. Okay, use the upper scale. I'm sorry, please, okay? I'm having issues with my throat, okay? Not too strong. But I just have to do this, because I like my friends to have this knowledge before they could carry out some of their experiment. And of course, get to learn how to verify Ohm's law. Alright, so if you are measuring voltage up to 1 volt, you use the upper scale. And how do you achieve that? Look at this cap. You can see 1 there. This one shows 1 volt. Is that okay? This one shows what? 1 volt. Look at it. So if you are measuring voltage up to 1 volt, this wire connected to this cap will be connected to this one. All right. But if you are measuring voltage up to 3 volts, which is the lower scale, then this wire will be connected to this cap, because this cap is meant to read up to 3 volts. You can see that. And of course, the cell that I have is up to 3 volts. Okay, the cell I have is up to 3 volts. So that's the reason I connected to this cap. All right, so that is all about the voltmeter. Let's talk about the ammeter. Although in this experiment we don't need the ammeter, but you just need to know about the ammeter. This is your ammeter, quite similar to the voltmeter. The ammeter has the upper scale and the lower scale. This is the upper scale, and then this is the lower scale. You notice that the upper scale measures from 0 to what? 5 ampere. So if you want to measure current up to 5 ampere, you use the upper scale. And how do you achieve the upper scale? Look at these 2 red caps. This one will measure up to 5 ampere. So if you are measuring current up to 5 ampere, it means you have to connect your conductor, your wire to this cap. All you need to do is screw up. Now I told you that this conductor in the voltmeter did not come with it. All right, I was the one that fixed it there because usually I use that point. Okay, so you can see it has gone up, so you just tighten your wire here. Although there is an opening, if you take a look, you would see this opening there. All right, through which you can fix your wire. You can fix your wire, and then you fix your wire there, which is your conductor. You can now screw back. All right. So this measures up to 5 ampere. But if what you want to measure is up to 3 ampere, say lower than 5, but not greater than 3 ampere, you can see the lower scale. The lower scale will do that for you. But to achieve that, you connect your conductor, your wire, to this red cap of 3. This represents 3 ampere. So all you need to do, once again, screw up, you can see, and then fix your wire. You can see an opening again through these points. Fix your wire there, and of course you screw back, tighten it back. You can see this point black, negative terminal of the current. These red caps are positive terminals. Okay, the same thing with the voltmeter. This is negative terminal, then these 2 red caps are for positive terminal. Okay, so let us take a look at our cell. The cell, I have my battery here. Let me bring out the equipment or apparatus I have here. This is my battery representing our cell. There are 2 batteries here. Each of them is 1.5 volts. So if we connect these 2, as you could see, in series, this is series connection because it is end to end. Are you following right? End to end. You can see I've decided to fix one conductor here, another conductor here. So the 1.5 plus 1.5 for series connection added up would give you 3 volts. Is that okay? Good. Take note, these conductors connected, this wire, they are not follow-come wires, okay? I just have to fix them so that once I want to demonstrate the experiment, I wouldn't waste time. It is your duty, your work, to connect this wire to the negative terminal. This is the negative terminal. And then this is the positive terminal of the battery. This side that has that cap, okay, is the positive terminal of the battery. Good enough. They are usually labeled on it, so you don't need to stress yourself. Okay, they are labeled. Downside there you see negative. So this is negative end of the battery. And then up, positive end of the battery. All right, so that is that for the cell. And then we have our resistors. This is resistance of 2 ohms. Let me bring out these wires. And then we have this resistor. The resistance is 1 ohm. You can see that. And then we also have this. This one is a resistor of resistance 5 ohms. Always labeled, so you don't have any problem identifying them. Okay, these are the resistors available to me. We are going to make do with that. All right. Then here I've got my key. This is my key. This is the key I'm going to use for this experiment. I use this to close this key so that the circuit will be complete. Alright. This key is called jaw key. We use it for potentiometer experiment. Are you following? We are going to demonstrate that in time. But we are not going to use this for this experiment, so I'm putting it back. Alright, I have shown you the materials that we need. The next thing we are going to do is to find out how we carry out these connections, all right? How do we carry out this connection? You know, usually in physics practical, you have your diagram to guide you and the instructions. So this is the procedure. Now this is the circuit. The first thing you do is to determine the number of connecting wires, because of course you know that you need to connect these things, all right? These apparatus, this equipment, so as to get the circuit to look like this. Are you following, right? Now to connect this circuit, first of all, you need to count the number of connecting wires so that you know how many wires you need for this circuit setup. And how do you count? I usually prefer starting with the negative terminal of the cell. It is not compulsory, but that's just what I like doing. Is that okay? And so from here, this is the negative terminal, the shorter side. This sign or this symbol is the symbol of cell of your battery, okay? These two lines. This shorter one is the negative terminal. This longer one is the positive terminal. So you have a wire that runs from the negative terminal, goes this way, and then connected to the resistor. This resistor is variable resistor. Actually, I am supposed to make use of a resistance box. Unfortunately, I don't have a resistance box. And so I'm going to make use of the resistors, all right? These standard resistors that I have. I'm going to make use of it. In your laboratory work, you'll be provided with your resistance box, okay? Where you'll be shown the resistance box and, of course, how to make use of it. That is what you'll be, taught in your laboratory work. Okay, but for now, we are going to use our standard resistors. And I'm going to make it variable. How? For example, by the time I want to run the experiment for, let us say, 3 ohms, I don't have 3 ohms resistor here. So what I'm going to do is to connect this 1 ohm resistor in series with this 2 ohms resistor. Are you following, right? For series connection, if you add, to get the total resistance, you simply add the resistance value. In this case, if it's in series, 1 plus 2 will give you the 3 ohms you are looking for. So in that case, I've made this standard resistance to be what? Variable resistors. Okay, let's move on. So one of the wire we have is this that runs from this negative end of the cell into the resistor here. So this is one wire. Are you following, right? Then another wire runs from this second end of the resistor to the key. This symbol represents the key. Are you following, right? This key. Look at it here. This bracket here represents the key. So a wire runs from this end of the resistor to the key. That makes up 2 wires for us. Then from this other end of the key, the wire now runs straight on to the positive terminal of the battery of the cell, making it the 3rd wire. So we have gotten 3 wires, 3 conductors, all right? We've gotten 3 conductors. Then this is our voltmeter. The voltmeter is connected across the resistor, just like Ohm's law said. All right? Current is directly proportional to the voltage, which is connected across the resistor. So this is the voltmeter. So we're going to connect this across the resistor. Now look at the wire you have. The wire came from this end as a conductor. That conductor or that wire that ran from the negative terminal of the battery, just from one point of that wire before it entered the resistor, before it was connected to the resistor, just from a point there, you connect a wire to the voltmeter. This wire will come from that one connected to the negative terminal. Are you following? To the negative terminal of the cell. So the wire running from these points will be connected to the negative terminal of the voltmeter. Okay? So this gives us our 4th conductor, 4th wire. Then from the positive end of the voltmeter, we will run another conductor, another wire to connect to that 3rd wire that was run from the key to the positive terminal of the cell. So you have this wire now. This will come from the positive terminal of the voltmeter. and then connected to this wire at this point. Once you do this, you've connected the voltmeter across the what? Resistor. So how many wires do we need altogether for this connection? 5 connecting wires. And you saw the way I showed you how to connect it. Good. In our instruction, we are to connect the circuit as shown in figure E2B above. So I'm going to follow this and then set up my circuit. Are you following right? Then once we do that, we are asked to remove or open the key and then record the voltmeter reading. That will help us to get the value of the electromotive force, EMF, of this battery. So let the connection begin. Alright, so starting with the negative end of our battery. This is the negative end. Are you getting me right? So I fix a wire there. That wire is our conductor, like I've said already. Okay, so from the wire, according to the diagram, from the negative terminal, we're going to run the wire to the resistor. Now for the first experiment, we are using resistance of 1 ohms. And so I'm going to pick this. Look at the resistance of 1 ohms. Now this wire runs from the negative terminal of the battery of the cell. You can see that from the negative terminal of the cell. Okay, so I'm going to connect this. All right, so I have something like this. Now this screw goes this way. This screw turns this way to tight. Turns this way to tight. Are you following right? Therefore, if I am fixing my wire, I'll make sure the wire also goes that way. The wire should be rolled this way. So when you are tightening this, the wire will not loose. If I move the wire against the direction of tightening, by the time I start screwing the screw there, are you following right? Or the knot, it won't tie. To rather be losing the wire. So I've done that. Connected to resistor of 1 ohms. You can see resistance of 1 ohms. Then from the resistor, we had a wire that was connected from the other end of the resistor to the key. Let me connect this from the second end of the resistor. Remember I told you the resistor tie, as in the screw of the resistor ties this way. So the wire should be also fixed this way. Is that okay? So that when you are screwing, the wire will not loose. So we've got this. Good. This is run to another end of the key. Look at the end of the key there. You can see it from this end of the resistor to this key. Alright, so I'm going to bring in my key. And then look at the screw. It tightens this way. Are you following right? Therefore, the wire will be fixed to go in that direction also. It is not a law. It's just to make sure you don't get in those trouble, trying to fix all these conductors or these wires. While you are trying to tie, the thing will be losing. So this screw goes this way to tie, and hence I fix the wire in this direction so that the tying will be easy. Okay, so we've achieved that. Now the next thing I am going to do is to connect another wire. You can see from the diagram, another wire conductor from this second end of the key, run it directly to the positive end of the cell. Good enough. I've already connected, a wire to the positive end of the cell. This is the wire. So this is the positive terminal. The positive terminal of the battery. You can see the wire. Positive terminal. And so it's going to run, connecting this to the other end of the key according to the diagram. So watch as I do that. And then the wire goes around like this so that I can now tie or screw the knots, ensure tight connection, please. So this is the first thing done. Take a look. I don't need this ammeter, so let me take it off. So this is the first setup, all right? Where the conductor, which is our wire, was run from the negative terminal to the resistor. Then another conductor from the second end of the resistor was run from that second end of the resistor down to this first point of the key. Then the other wire from this second point of the key ran into the positive terminal of the cell. So now looking at the diagram, we have completed this part of the circuit. We are now left with this part where the voltmeter is connected across the resistor. Now how do we achieve this? It's simple. The two wires that run from the two terminals of the cell, negative and positive terminal of the cell. Now one of the wire from the negative terminal of the cell was connected to one end of the resistor. Just before being connected to this end of the resistor, you have a point where you need to connect a wire from. That wire will be connected to the negative end of the voltmeter. Then the other wire, which is the third wire from the positive end of the cell, this. Just before the point it was connected to the other end of the key, you need to connect a wire from a point to the positive terminal of the voltmeter. So let us do this and see. So based on that, we are going to be interested in two points of this cell, that is from the negative point and from the positive point. Then as it's going out, I created two parts where you can connect the voltmeter across the resistor. Yes, just like I showed you in the diagram, the wires, all right, running from the voltmeter would have to be connected to a point just before the other wire entering the resistor, and also has to be connected to a point just before the wire running into the key. Okay, that's what you saw in the diagram. Once again, take a look. Connect the voltmeter across the resistor at a point just before the wire running into the resistor from the negative end of the cell. Connect your voltmeter there, and then the other wire running from the positive end of the cell into the key, you connect another wire just before the one entering into the key. So that's just it. One thing you want to take note of is the fact that this point of the voltmeter is that connected to the negative. So this point of the voltmeter is negative. While this point that runs into the wire coming from the positive point or terminal of the cell, this point of the voltmeter will be the positive point. Take note, positive to positive, negative to negative. That's how we achieve that. So we go. Now this is my voltmeter. All right, this is my voltmeter. This is the negative terminal of the voltmeter. The wire coming from me to be connected to this point. Are you following, right? Because this end is the negative terminal of the cell. And then we have this. This is the positive terminal of the voltmeter. This end of this terminal, this wire coming from there will be connected to this point. You can see that, right? To be connected to this point just before the wire entering the resistor from the positive terminal. So let us do that and see, please. And I'm going to bring this to this point. So I have this wire. Take notes. This is the positive terminal of the voltmeter, and it goes this way. I'm connecting it to this point. So you have to create a space here. Are you following? It's either you break this wire here and then pull out some so that you can be able to make these contacts. Is that okay? And then we have here also this wire runs from the negative terminal of the voltmeter. It is going to be connected to this bridge here. Are you following, right? That's that wire coming from the negative terminal of the cell. And so I'm going to have this. And so I'm going to tie this at this point. All right. So I have achieved the connection of the voltmeter across the resistor. You can say that the voltmeter has been connected across the resistor. So this is what we get. All right, so the cell connection is complete, as you can see. And so the voltmeter has been connected across the resistor. Like I told you, this is our resistor. The resistance value we are using for the first experiment is 1 ohms. So you can see that the voltmeter has been connected across it. Good. Let us now see the next thing we are to do according to the instruction. Connecting this circuit is the most important thing. Are you following, right? When it comes to electricity experiment, just knowing how to connect the circuit, very important. But I'd like to also say something quickly. If maybe, okay, all right, I think maybe if we try to see how the voltmeter reads, then I can tell you what I want to say at this point. Alright, I hope you enjoyed this video lesson. Please kindly subscribe to my channel, like this video and share it to other friends and scholars like you so that they can benefit from this video lesson. If you have a question, please leave your question in the comment section and I'll be there to respond. Alright?